motion. Now, when we talk about circular motion, I will say there are two approaches. One of them is to connect what is really called rotational motion. Then we might, okay, find, we call it rotational or angular motion, and we're gonna connect it with what? With what is really called uniform circular motion. And when we say uniform circular motion, remember we have that discussion before. We said here, what is really constant? It is constant speed. But since the object is moving over a circle, then it's gonna have acceleration. And that acceleration, we call it the centripetal acceleration, or sometimes we call it the radial acceleration. And it is the magnitude of the velocity squared divided by r. We did talk about this before when we were in Newton's laws. But now we will connect this, as I said, with what? With rotational motion. Then I have my object that is gonna be maybe sometime here, and then now is gonna move to here. Then in the same time that my object did kind of a displacement over the arc, it did make a displacement here, theta, and that is, we call it angular displacement. Okay, whenever I'm gonna say angular, the other equivalent word for it, it is rotational. Then that delta theta is gonna be theta minus theta initial. Now, theta can be defined to be the final angular position, and that is going to be measured in radians. And I will say theta 0, it is going to be the initial angular position, and also it is in radians. Okay. Now, what I can do is I can say, okay, since this is displacement, I need to think about the direction. And for the direction, I will say, and this is like a convention. It's not something like has an origin, okay? But it is, we will agree that if the object is rotating anti-clockwise, okay, then the displacement is gonna be positive. If it is moving clockwise, is gonna be negative. Then this is the notation that we are going to use. In the same time, I will define what is called angular velocity. The same way that we did with the linear motion, we're gonna go the same order. Now we use for it that curve W, we call it omega. This is a Greek letter. And that is gonna be the change in the angular velocity over the change in the angular displacement over time. And of course, this should have a unit radians per second. And again, it's gonna have the same, like the same kind of notation for the rotation. When it is moving clockwise, it's gonna be negative, counterclockwise, it's gonna be positive. Again, also, remember here, we said this is the average. And we can say, what is the instantaneous? The instantaneous is gonna be the limit as delta t goes to 0 for delta theta over delta t. And For us, we don't have, of course, calculus here. Then I will say we are going to do the tangent at any point. Any questions so far?
No.
No, okay. And now I will say, I'm gonna move to now, I will say connecting or the relation between, I call them linear variables. My linear variables, they are going to be, we're gonna use for displacement S, we're gonna use for velocity V, and we're gonna use for, yeah, this is why, because it's from math, like they usually use S. This is here displacement. Okay, now, okay, between linear variables, and I will say, either I will say rotational, or I will say angular. My angular, they're gonna be theta, omega, and alpha. Now, what are these here? I will say, okay, theta is gonna be the angular displacement. Omega, it is the angular velocity. And alpha, we did not talk about yet, it is angular acceleration. Now, something that we need to know, that S equals theta times R. What does that mean? That means if your object is moving over an arc that has a length S, and this is theta, and this is the radius of the track, then S equals theta times R. Again, V equals omega times R. And finally, A equals alpha times R. Now, alpha, as I said, it is the angular or rotational acceleration. And we can define it as the omega, changing omega over time. And of course, it's gonna have units of radius per second squared. Any questions? There are gonna be many occasions where you need to change radians into degrees or degrees into radians, because the equation may like ask about like an object that is moving in, let's say, 60 degrees. Okay, you cannot use the 60 degrees. You should have what? You should have the radians. And I will say, we know that 360 degrees are equivalent to 2 pi radians. Then, for example, if I have 60 degrees and I want to change to radians, I will say 60, one here, and here I will say this is degrees times 360 times 2 pi radians. Now is 6, then is going to be pi over 3 radians. You can leave it like this if you will not use, or if you were not asked about the actual number. Or what you can do is you can do the following. You can go to your calculator, find pi on your calculator, divide it by 3, and get that in decimals.
Ooh, can you go back up just?
Yes, yeah, just I was adding pages. Is that good?
Yes, that's fine.
Okay, then here I have calculated what is the equivalent of, what's the equivalent of the degrees here. Now, one thing that I want you to know here, that in this chapter, especially, we're going to have too many formulas, too many equations. Then you have to pay attention and, collect them in one place because they are scattering everywhere. Then we have so many. Any questions? Okay, now, also, another thing that is really related to circular motion, two parameters that we are interested in, period and frequency. Okay, then I have my object on my circle here. It's gonna go in a circle. Maybe it has started somewhere here, all right? And it's gonna move maybe in this direction, and then it's gonna come back. Now, when it's gonna come back to the same point, we call this one cycle. Now, we defined period as the time required to complete one cycle or one oscillation. Now, that time should be always in what? In seconds. And the second one is going to be what is called the frequency. Okay, by the way, for period, we are using capital T. Okay, T here, it's not tension, it is period. All right, and frequency, we use for it lowercase f. And it is the number of cycles per unit time or per second. Then I am looking how many oscillations I have in 1 second. And that one, the unit for it, it is hertz. There is a relation between frequency and period. F equals 1 over T, and of course, T should equals 1 over F. You can calculate the frequency from the period, and you can calculate the period from the frequency. Also, I can say something like this, okay? The object will complete 2 pi times r distance. Why? Because if this is the center of the circle, then it's going to go over the circumference of the circle that has a radius of r. The circumference of the circle is 2 pi r. Now, the speed here, we said this is uniform speed. This means constant speed. And then it can be calculated as total distance divided by total time. Now, total distance here, it is 2 pi r divided by t, which is the total time for one cycle. Then I can connect v with the period in this relation. I can also write another equation connecting with the frequency. Then the speed of the object has to do with the period of time, and it has to do with the frequency.
Can you move it up a little bit, please?
Is this enough or more?
Just where it says period, just the last page, please.
Yes.
Thank you.
You're welcome.
Thank you.
You're welcome. Yeah, questions here. Okay. I assume no questions. All right, then now here I will move to the next thing, which is I'm gonna continue with this chapter, okay? And all right, just 1 second. Okay. Okay, then now here, as I said, you have all these derivations that we did use and like all these equations, okay? Then you should be aware of having, as I said, all of them. You're gonna have them available for you, and you need to maybe collect them in just one place, so that when it is the time of your exam, you will not start flipping the pages in the last minute, and you will not be able to maybe find one of the equations that was really, maybe it's like the question was just, you need to apply that. Then I advise you, have an index card next to you, record all these things in one place, so that you will be able to have the things going around with you correctly. Okay. I will say here, let's work on one problem and show you how we're gonna solve. Then here, I will say, just I wanna find, like there is a centrifuge that is spinning at, then this is from your textbook. It is talking about an object that is really spinning or rotating with that speed, which with that rate, which is, okay, I will not say what's that until I write it, 5400 revolutions per minute. Okay, now in industry, most of the time, we have a practical interest in some of the parameters, or it's easier to us, you know, if you will go to somebody who's working with machines that they're gonna rotate, and you're gonna say, is it rotating with like 15 radians per second? You will not be able to find an answer because they don't know what are the radians, but they know something called RPM, which is revolutions per minute. Now, if you look at this, it is revolutions per minute, which means it is displacement divided by time, then this is omega, Okay, now that omega, you will not be able to use it in the calculation unless it is in radians per second. This is the reason why I will show you now how we're gonna convert this. Then I'm gonna say 5400 revolutions or cycles or oscillations or whatever you wanna say, divided by minute. And then 1 minute is 60 seconds. I need to convert into seconds. And 1 revolution, it is 2 pi radians. And then by doing this, you will be able to find what is really that. You can say it is 180 pi radians per second, or you can calculate exactly what is going to be the number. But as I said, you need to convert. You cannot work with it. Now, the first question here asking about find the period in seconds and frequency in hertz of this motion. Okay, now what I can do is I can say, oh, sorry, what I did. Okay, they want us to use this as frequency. By the way, this is not correct.
What's not correct?
No, I mean it is confusing. Okay, why it is confusing? Because this is why I have many objections against this textbook. If you will search wherever you want to go, you're going to find RPM. It should be an omega. It's not frequency. Okay, in your textbook, they are dealing with it as if it is the frequency. Okay, follow what I am writing. Forget about what you're gonna find in the textbook. Okay, I think here I need to repeat that calculation here. I think it's not correct, but just let me. Okay, but I will say this is the speed. It's not the frequency. Okay, then follow what I have here. Okay, then I will say, I would write here, ignore solution in textbook. Okay, now let me have that 5400 multiply by 2 and then divided by 60. Yeah, no, it was correct. 180, I did write 180 originally. Okay, pi radians per second. Then this is my omega. And I want you to know here that omega equals, and this is another equation that I'm gonna provide you with. Omega, it is 2 pi times f. Then when I will say omega is 180 pi, okay, should equals 2 pi times the frequency, then the frequency here is going to be 180 divided by 2, which is going to be 90 hertz. Okay. They did something maybe like similar in another way, but like I don't like to when they're gonna say 5,400 revolutions per minute is the frequency. It's not. Okay, it's not. Okay, then this is really part A. And here I calculated the frequency. I can calculate it T as 1 over F, then it's going to be 1 over 90 hertz. And that is going to be 1 divided by 90. And that is going to be 1.1, 10 to minus 2. Okay. Okay, now also, they have provided us with the radius, and the radius is 14 centimeters. You cannot use it in centimeters. You need to convert into meters. And they are asking, what is the linear speed? Okay, for the linear speed, we are going to say V is omega times R. And here, I need to have my omega in radians per second. Then I will, I will say 180 pi radians per second times 0.14 meters. And I will say I need to multiply. You can leave it actually in pi, but always if you're gonna have as multiple choice is gonna be, asking for a number. Sorry. Then it's gonna be 180 times pi times 0.14. And that is gonna be 79 meters per second. Any questions?
No, I just need a second to copy.
What happened to the unit of radians? How did we get rid of that?
This is a very good question. I was waiting for it. Okay, excellent. Okay, now, as you can see here, I have radians per second times meters. And then I told you like the unit, the resultant unit, it is meters per second. Actually, the unit of radians, it's not considered to be a physical unit. This unit is from math. And you're gonna see whenever we are going to derive equations, we're gonna ignore it, okay? Now, what I can say, or what I should say maybe, is like I can say radians per second, and I can say only per second, okay? Then you will not include it in your unit for the velocity, like here for the linear speed. You will not include it in units of angular. We will talk about angular momentum. You will not include it. Then it's just like, as I told you, it's gonna be like you get, even if you will leave it, that's like you will not write radians, that's okay, because this is a unit from math. It has nothing to do with my physics, okay?
Okay, thank you.
Thank you very much for this precious question. Yeah, I was waiting for it, but usually I will not talk about it unless somebody is paying attention to that. Because like sometimes I feel you're gonna maybe, I feel you will be confused. Okay, did I tell you that I got my vaccination on?
Yeah, how are you feeling?
Yeah, I was good, like just this tonight and today, I have these like kind of maybe headaches. I'm not sure if it is related or not, but no, I'm okay. Like I didn't have any chills, any like, and usually they said like the first one is not gonna have any side effects. They said the second one is gonna be the one that you might have. Yeah, but like I have a headache like that suddenly is gonna hit, and I'm not sure if it is related or not.
Have you eaten or had something to drink yet?
Yeah. I like because I am on medication for my knees because I have also like kind of pain and stuff. Then I need to take a medicine in the morning, and then I need to, have breakfast. And believe me, breakfast is the most important meal in your day. Yeah, for me, like I will have it as early as I can. I
Yeah.
can't function without food. This is our fuel, right?
No, that's correct.
Yeah, but like I feel also maybe I'm a little bit warm, but just maybe I am, but because sometimes I feel that they shouldn't talk about these side effects because sometimes even you don't have them, but you can
That's-
feel them because of they said, yeah. And this is the reason maybe this morning I feel like I'm a little bit warm. I feel I'm a little bit like having these headaches, but okay, good. Yeah, but I'm so excited that I have my vaccination. Yeah, yes. And I, of course, everybody go and do it.
I mean, it's just one step closer to having live sessions again.
Again?
Having in-class sessions.
Me too. Me too. Me too. I don't know if like everybody is looking for that. But like sometimes in the morning, I will say, oh, what if I need to go to school now? Because now we are used to be home and, maybe now COVID is changing our lives. But of course, I am the first one who's going to come back to class. Yeah, we will come back in fall. Yeah, for
I don't
sure.
think we're gonna make it in fall.
Yeah, they said we're gonna have the classes in fall on ground, yeah, for all Cal State. Yeah, but for the colleges, like for Cerritos, they told us maybe mostly it's gonna be online. But I think things are should change anytime now because if you look at the numbers, they drop significantly, and they start opening things, and I hope that things is gonna going back to normal. All right.
Professor, will this be on our upcoming test?
Again, can you repeat that?
Will this be on our upcoming test?
Yes, of course.
Okay, I was just making sure. Are you gonna tell us what's gonna be on the test today or on Tuesday?
On Tuesday, yeah, because we still have time.
Okay.
Yeah, but I did not start writing the exam for the exam number 2, but I will, hopefully during the weekend, I will finish it and I will talk to you briefly about what we are going to have in the exam. Okay?
Okay. Thank you.
You're welcome. Okay.
Will you make
yeah.
sure to post this today's lecture up?
Yeah, please, if I will forget, just remind me because I have a class right away after your class, and I have another class right away after the other class. I will not finish until 11. Then by this time, it should be I should be posting that. If I forgot, just let me remember, okay? Like, yeah, just send me an email. Thank you. Okay, now we are going to talk more about applications of like radial acceleration. Why we call it, okay, like the other name for it is centripetal acceleration. We call it radial or we call it centripetal. Now, in order for us to talk about that radial acceleration, this is the radius. Of course, it is always towards the center. Its value can be calculated as v squared over r or omega squared times r. I told you so many equations in this chapter. Now, what we are going to do is we're gonna apply in Newton's second law for uniform circular motion. And briefly, what we did before, we said sigma F equals MA. This is Newton's second law. Now, what's going to happen today is I am moving over a circle, then my axis, they're going to be like this. This one here, I will call it the radial. And that one, I might say it's the y-axis. Now, I will split my equations into two equations. One of them is going to be along the y, and that is we don't have acceleration, then sigma Fy equals 0. Now, along the radial, I'm going to try to find what are the forces in this direction, and I'm going to make it mv squared over r. Then this is going to be my focus today. I will have, this is my strategy for solving. I will have this equation coming to me talking about what is really the forces along the radial direction. And that is going to be equal mass times A radial. And along the y, we don't have any acceleration, then sigma F is going to be 0. Okay. Now we are going to apply this to more than one problem. Maybe they're going to be like very similar to each other, like in derivations, but I will say whenever we are talking about this motion, we are talking about very specific examples that we have in life. And I will talk about 3 examples here. I want you to pay attention to. We're going to derive the equations for these. They might look like the same, but there are slight differences. I'm going to add pages just here. Okay, now. Okay, example 1 is going to be a car on a flat curve. Now, when I say a flat, this means it does not have any angle. I don't know if you, all of you, like if you're driving, whenever you are going to exit the freeway, I don't know if you have noticed that the road is going to have an angle, okay, like this, okay? Then your car is going over that, okay? And you feel that there is a kind of an inclination. This road here, we call it banked road. This road, when it is flat, I call it an unbanked road, or we call it a flat road, or we call it sometimes level road that doesn't have any inclination, okay? Now, I want to ask you, did you ever, and don't repeat that if you did it in the past, did you ever try to have your car going in circles like this on a level road?
Yes.
Yes, oh, wow. Okay, anyone else? Is it interesting? Huh? Yeah,
It's fun.
Fun, it's a lot of fun, yeah. Oh, yes. Oh, donuts. Yes, yes. Ashley, did you do that? Yes.
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 Me and my boyfriend.
You know, oh, wow. All right. This is much fun, right? Like it?
Yeah, it's kind of scary, but once
Yes.
you do it, you get used to it.
Yes. Okay.
As soon as you get over the spinning motion and it just feels level, you're able to look.
Yeah, but for me, like, it's so scary. I don't know if you, I was once visiting Long Beach, and there is an area there. I think they are shooting movies there. I don't know what's the name of the area. I forgot.
Like 7th Street all through downtown, that's a racetrack.
Yeah, the racetrack. Yeah, did you ever go and watch like cars there?
Yeah, no, the Long Beach Formula Drift over at the Long Beach Pier, and
Yeah.
then they also have the F1 out there.
Yes.
It's fun.
Yeah, I saw that once by like, just we were like, we're going to the beach and then suddenly we start like seeing like the people like, running towards something. And then I discovered that this is the place. But of course, there they have the roads not flat. I will say more like level roads, and it's a closed area where I think nobody can enter there except the people who are racing. Then I will say here, as from the experience of some of you, you were in an environment where you want to try maybe to make your car go in a circle without having any angle. And here you're going to depend on what is called aesthetic friction only. Then the only thing that is going to keep the car is what is friction. Okay. Now I said, always I need to draw free body diagram. Then I need to draw free body diagram here for this car. This is the center of the car. This is my Y, and this is my radial direction. Okay. Then I have the acceleration. This is the direction of the acceleration. Now what I have here, I have the normal here, and I have mg here, and I should have the maximum force of friction, Fs maximum here, so that it will keep the car in that position, in that curve. Then I will say sigma Fr should equal mv squared over r. I know that. Then Fs maximum is going to be the one that is going to keep me on this track. Fs max is ms times the normal. I can apply the second one, which is sigma Fy, to find the normal, because remember, whenever I'm talking about a friction, I should have something related to normal. Then I will say sigma Fy is going to be normal minus mg should equal 0. And from that, I can say normal equals mg. I can put this back here. And then v squared equals mus times r times g. Now, something that I want you to notice here, that velocity does not depend on the mass of the car, right? Otherwise, they're gonna say, if the car mass is then it can go. If it is, okay, then here it has nothing to do with the mass of the car. Now, it depends on two factors. Like G is constant throughout the earth. R is the radius. And usually the radius is fixed, right? Because this is a road that was designed before you, then it has that radius. But it depends also on a mus. And that mus, I will say, I cannot depend on that, because that mus depends on many factors. It depends on the car. It depends on the driver. It depends on the weather, like many factors, right? Then I will say, then maybe it's not safe to have these roads unbanked. And this is maybe the reason that they started saying, all right, this is not going to be safe enough. We need to find another way of getting these cars going safer. And then we start thinking of having banked roads or having the roads that they're gonna have an angle. Okay. Any questions here?
Is the equation, the third equation at the bottom, that's also mu s?
Yeah. Yeah, this is where if you want to calculate, if you are going to calculate the speed that the car can go safely, you're going to say V equals the square root of mu s times R times G. This is how you are going to calculate the maximum velocity that the car is going to go. Now, if the car is gonna go in a direction that is gonna go with a velocity more than this, it will go out of the track. Okay?
Yeah.
Okay. Any questions? All right. Shall I move to the next?
I just need like one
Yeah,
more.
okay.
Professor, another homework assignment posted while we were in class. I was just wondering, is that gonna cover information that's gonna be on the exam?
Yeah, that's chapter 5, yes.
Okay.
Yeah. You are talking about 5? Chapter 5 or?
Oh no, the one they just posted today. For the 14th, I think it's due.
That one, I think is not gonna post until 9:30, isn't it? Let me
I think it was supposed to, but I don't know. I saw the notification on my phone while we were in class. I was just wondering.
It was posted, yeah, I think, yeah. Homework 7, yes. And there is another quiz also related to today's material. Today is March 4th. It's gonna be available 9:30 after we are done, like in 5 minutes or no, yeah, like about 15 minutes, okay?
What's the due date for that?
For that one is a week again.
All right, thank you.
If it is available today is what?
Thursday to Thursday.
Yeah, Thursday. Then it's gonna be Thursday before the exam, like 8 a.m.
Okay,
Yeah,
so
I don't know. Like, okay, yeah. Thank you very much. Okay, yeah, I have noticed something that I don't know if you have noticed that I have graded, finalized your quizzes and homeworks. I have noticed that some of you're gonna start working on them. Even if they are past due, don't do that because you will not get any credit for that.
still need to
Credit
practice
to
it.
be given, because like sometimes I don't know, like I will forget to hit the button which is saying don't let the students start working on it if it is past due. And you are some of you while you are in class, and this is like for me, like is not something that I like you to do. Like I have noticed that some of you're gonna start working on your quizzes while we are in class, which is not okay. This is not what I'm looking for. This is the reason why I am posting them. Like I will make them available 9:30 so that when we are done from the class, and they will be, they will be gone before the lecture next time. Then when it's gonna come to Thursday, just before the at 8 a.m. is they're gonna they're gonna disappear. Okay. Any questions? I don't know why I cannot share. Just 1 second. Then if you will find by accident, you're gonna find one of the quizzes that is still open and it's passed, you don't like do it because you will not get a credit for that. Okay. All right. I think I can maybe I have about 9 minutes where I will cover the banked road. And when we have the banked road, I will say we're going to have the car on that road that is really having that angle here. Okay, and this is my radial, and this is my Y, the red. Now, now I will assume no friction at all. Of course, if there is friction, it's gonna help more. But here I'm gonna assume we don't have any friction, then I will say this is my MG, and the normal should be this way, okay? Now, if this angle is, let's say 30 or theta, then this angle is theta, and I will have here normal cosine theta, and here I will have normal sine theta. Then I can say here, sigma FR equals mv squared r. The force that is in this direction, it is n sine theta. And this equals mv squared over r. This is number 1. Number 2, it is sigma Fy equals 0. And that is n cosine theta minus mg should equal 0. What I can do here, it's another trick that I can use it to solve equations, which is I will just divide 1 by 2. Okay? N sine theta divided by n cosine theta equals mv squared over r divided by mg, and n will cancel also. This is going to be tan theta, and that is v squared over rg. Then v squared is rg times tan theta. For any road, we're gonna find that the road is characterized by r now and theta. In order for this car to go safely over the road, it should stick with that velocity. Any questions? Okay, I'm done. I'm done for today, and just if you have any questions before we leave, and I will see you Tuesday.
Thank you, Professor.
You will come by.
Thank you, Professor.
Bye.
Professor, I was wondering, do you have any other office hours if we can't make it to the 7 a.m. one, like for your other classes?
No, all of them for the class because no, all of them are in the morning. The reason is all my classes are morning classes. They're gonna be 8:30. Then I have them just right before our classes because Wednesday and Monday, Tuesday, Wednesday, and Thursday, I have classes at 8:30.
Oh, okay. I get you.
Then if you want to join me on Monday, you are more than welcome to do that.
Okay, I'll try to stop by.
Okay, yeah.
All right. See you next week, Professor. Bye.
Goodbye. Thank you, everybody. See you.